Section 1.4, Topic 4, Derived SI Units. The SI base units in Table 1.4 are used to derive the units of other quantities. To do so, we use the defining equation for the quantity, substituting the appropriate base units. For example, speed is defined as the ratio of distance traveled to elapsed time. Thus, the SI unit for speed, meters per second, which we read meters per second, is the SI unit for distance, length, meters, divided by the SI units for time, second. We will encounter many derived units, such as those for force, pressure, energy, later in this text. In this chapter, we examine the derived units for volume and density. Topic 5. Volume. The volume of a cube is given by its length cubed. Thus, the SI unit of volume is the SI unit of length, meter, raised to the third power. The cubic meter, or meter cubed, is the volume of a cube that is 1 meter on each edge. Smaller units, such as cubic centimeters, sometimes written as cc, are frequently used in chemistry. Another unit of volume commonly used in chemistry is the liter, which equals 1 cubic deciliter and is slightly larger than a quart. The liter is the first metric unit we've encountered that's not an SI unit. There are 1,000 milliliters in a liter, and each milliliter is the same volume as a cubic centimeter. The terms milliliter and cubic centimeter are used interchangeably in expressing volume. The device used frequently in chemistry to measure volume is illustrated in Figure 1.20. Syringes, burettes, and pipettes deliver liquid with more precision than graduated cylinders. Volumetric flasks are used to contain specific volumes of liquid. Figure 1.19, Volume relationships. The volume occupied by a cube that is 1 meter on each edge is a cubic meter. Each cubic meter contains 1,000 cubic decimeters. A liter is the same as a cubic decimeter. Each cubic decimeter contains 1,000 cubic centimeters, and each cubic centimeter equals 1 milliliter. Section 1.4, Topic 6, Density. Density is a property of matter that's widely used to characterize a substance. Density is defined as the amount of mass in a unit volume of a substance. Density equals mass divided by volume. The densities of solids and liquids are commonly expressed in units of grams per cubic centimeter or grams per milliliter. The densities of some common substances are listed in Table 1.6. It's no coincidence that the density of water is 1 gram per milliliter. The gram was originally defined as the mass of 1 milliliter of water at a specific temperature. Because most substances change volume when they're heated or cooled, densities are temperature dependent. When reporting densities, the temperature should be specified. If no temperature is reported, we usually assume that the temperature is 25 degrees Celsius, close to normal room temperature. The terms density and weight are sometimes confused. A person who says that iron weighs more than air generally means that iron has a higher density than air. 1 kilogram of air has the same mass of 1 kilogram of iron. But the iron occupies a smaller volume, therefore giving it a higher density. If we combine two liquids that do not mix, the less dense liquid will float on the denser liquid.